So today we'll talk about alkenes, all right, and alkynes is the other one as well. Alkenes, of course, we talked a little bit about this yesterday, and I did go over a few examples here, but we're just going to review real quick here. Alkenes, of course, are unsaturated hydrocarbons. Make sure you guys know that. Like I said, I think I suggested to you guys yesterday, I think it was your class, that maybe make a sheet for each one. Maybe an example, maybe a general formula, unsaturated, what kind of physical properties they have, etc., etc. Unsaturated hydrocarbons containing a double covalent bond in the parent chain, so it has a double covalent bond. The general formula, because you have that double covalent bond, you are getting rid of two hydrogens. Because you're getting rid of two hydrogens, those two hydrogens, that's where you're getting those two extra electrons to form that double bond there. Okay? When you go to name alkenes, you have to name the parent chain must contain the double bond. The double bond is the main feature here, just like I said yesterday. It's the main thing, it's the main feature. So we need to make sure we include it in the longest chain that we can. Okay? And then, of course, you're still going to add on the other groups like you did before. You also have to tell me where that double bond is located. Okay? The ene part is going to tell you that it's a double bond, and the number is going to tell you the location there for that. Okay? So here's a couple examples here that we'll do, once again, from yesterday here, which is, let's see here. The first one here was pent, so I know I got 5 carbons, 1, 2, 3, 4, 5, and then I said the 2, ene, 2 is telling you where the double bond is, okay? So 1, it's not after this first carbon, it's after this second carbon right here, so I'm going to put a double bond in there. Pent 2 ene, okay? You're going to fill up the rest with H's, and then you're good to go. So remember, each thing needs 4 around it. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? All right? So each carbon needs 4 things around it. And like I said, so that's what pentene would look like. Okay? The next one is 4-methyl-pent-1-ene. So 4-methyl-pent-1-ene, once again, I got to start at the end, as always. Okay? When you look here, this is where you want to start, this part right here. That's going to tell you, hey, I got ene, that's a double bond. Apparently it's on the first carbon, that's what it tells me there, and I need 5 carbons in a row. So that's all the information you're going to get from there. That's quite a bit. Pent-1-ene, so after the first carbon here, I'm going to put a double bond there. If you want, you can start from the right side as well. So you could start with this one here and make that the double bond. It doesn't matter. But once you do that, okay, what you have to understand, we're going to get to this here, is that you have to get to that double bond as quick as possible as well. So when you go to name things or draw them, you have to get to that double bond as quickly as possible. That's the main thing here. Everything else is just add-ons. All right? So for methyl, well, this is my carbon 1 here still, right here. That's carbon 1. 2, 3, 4 has a methyl group on it. And that would look like that. All right? So fill in the rest with H's, of course. So let's see. This would be H2 here. 4 things around there. That would be an H, 4 things. I need 2 there. I need 1 there. And I need 3 there. Good? Yes? Questions, anyone? Yes or no? Good? Yes? Okay. Moving on here. Then we got, this is as far as we got last day here. Got a couple more examples here for you. 2,3-dimethyl hex 2-ene. Actually, you know what? Why don't you guys go ahead and do the first one for me just right now, and then we'll double check it here. 2,3-dimethyl hex 2-ene. Go ahead and do that one, and we'll just double check it here. Okay, so you should always start at the end, right? Hex 2-ene is what I'm looking at. Hex 2-ene is, hex, of course, is 6. 1, 2, 3, 4, 5, 6. Make sure you know the prefixes as well. Hex, hept, oct. We don't do those a lot. Make sure you do those, right? Those are probably the uncommon ones. 6, hex 2 means I got a double bond there after the second carbon. It says that on the second carbon I also have a methyl dimethyl, so I have a methyl here on the second carbon and a methyl perhaps here, and you can put them on top, of course, it doesn't matter. And on the third one I also have a methyl. All right, so it should look like that. That's the basic structure there. Now I'd say probably let's go back in and start filling in some H's here. So H3, of course, 1, 2, 3, 4, don't need any H's there. There's 4 things around that one. 1, 2, 3, 4, 4 things there. I need a 2 here, and a 2 here, and a 3 there. All right? Now, I'll scooch that back up. There you go. Okay. The next one here is methylpropene. Now, you'll notice that this one doesn't have a number that goes with it. And you might say, well, why is there no number? Do I have to use a number? What do I assume here? Well, the thing is this. You have to use a number to identify where that double bond is. You have to. There's only one exception. And the only time you get an exception is when it doesn't really matter. All right? But if you got like pentene, you're going to have to make sure that there's a number with that because I need to know where that double bond is going to go. So it's going to be pent1-ene, pent2-ene, pent3-ene, for example. You have to make, you have to make sure you tell me where that double bond is. This one doesn't have a number. So I guess in that case there, we better take a look at what this looks like. First of all, propene is the last part here. Propene is, of course, 3 carbons in a row. Prop is 3, right? And then it says methyl. All right, well, let's see here. Methylpropene. Well, the first thing before I even put the methyl on there, I have to put a double bond here. So let's put it, do you want to put it here or here? Where do you want, left side or right side? It doesn't matter, right? Sure, I'm going to put it on the left because I do left to right. I'm going to put it here. But do you not agree that, does it really matter if I put it there? Because aren't those two the same so far, right? Yes? Just flip it around, right? So that's why in this case, there's no number with propene because there's only really one option. Doesn't matter how you draw it, you're going to get the same diagram. Okay. Now, the next part here is the methyl. All right. Where am I going to put the methyl here? Do I put it on, obviously this is carbon number 1 for me here. This is 2 and this is 3 there. Which carbon should I put it on, 1, 2, or 3? Where should I put the methyl? 2? Why? That's right. If I put it on 1 or 3, I'm going to put another C onto here. That's a 4-carbon chain. That's not propene anymore. That's butene. Okay? And I can't put it here because same thing, 4-carbon chain. So I really only have one option. You might say, well, why is there no number with methyl? Don't you have to put a number there to represent where it is? Yeah, usually you do. But once again, in this case, there's only really one option because I have to put it there because otherwise, if I didn't, I'd have a 4-carbon, right? So I'll show you, look, if I put it, let's say I decide to put the carbon here, right? Well, look, that's 1, 2, 3, 4 in a row. That's not propene, that's butene. So I can't do that, right? I can't put it at the ends because it changes the length of that structure. So I got to put it there. So that's how you're going to kind of determine that one. That one's a little bit tricky. 2 there. Let's see, that's 4. And then I need another 3 there. All right? So that'd be methylpropene. Good? Yes? All right. Now, next, we're going to name some of these structures here. So, naming, of course. You guys tend to not like this as much, but that's okay. Let's see. First of all, find the longest carbon chain containing the double bond. So guess what? You might have a shorter carbon chain this time, but if it's shorter, that's okay, but it has to have the double bond. So you might not be able to make, you know, a 8-carbon chain anymore. You might only get 6 out of it with the double bond. Well, that's what you've got to use, okay? Because remember, the main feature of this is the double bond. It's the main feature, right? All right, so there's my long carbon chain there. That's 4 in a row, of course. So I would call that, what color can I use to show that? Green, do you think, today? Oh, yeah. That would be, of course, butene, but I have to tell you where the double bond is. You have to start from the left or the right, of course. So it's either going to be 1 after the second or 1, 2 after the second. Either way, it's after the second, yes? So this is called but-2-ene. Okay? There's no add-on stuff, so that's all you need to have for that one. Remember, you have to get to the double bond with the lowest numbers possible. Once you've determined that, then that's the way you have to do it. All right? Let's look at this one here. Let's see. Well, 1, 2, 3, 4, 5, 6. So that's hex. That's good. 1, 2, 3, 4, 5, 6. That's another option. 1, 2, 3, 4, 5. Not quite as long. 1, 2, 3, 4, 5, 6. That's an option. So there's quite a few options here. Whatever option you decide to pick here, you have to include the double bond. So I guess in this case, my easiest one would be to do this one right here. Okay. That way, like I said, nice straight across, easy to add, see what's added on here. So once again, let's see. 1, 2, 3, 4, 5 1, 2, 3, 4, 5, 6 carbons, sorry. So 6 carbons is, that's hex. And then you're going to put a number in there, hexene. Okay. How am I going to get to that double bond quickest possible? Using this long chain here. So 1, 2, 3, or 1, 2, 3. It looks like 3 and 3, right? Looks like pretty good to me. So 3, I would say, no matter which way you go. Which way should you go now is the question. Well, you know, that's the main thing, right? The double bond is the most important thing. However, you know, after that, if you can use lower numbers for the add-on groups, like in this case here, guys, it's not going to matter if I start at the left or start at the right, right? I'm still going to get hex 3-ene. That's the main thing. That has to be the first priority. But after that, okay, these are the little things that are going to be different for each, you know, that could possibly trip you up here. After that, you know, I look at this and I say, which way would be better? Is there a better way to determine which end should I start from? If I start here, 1, 2, 3, 4, 5, 6, then let's take a look at what numbers am I going to be using. I'm going to be using 2 has an add-on group, 3 has an add-on group, and 4 has an add-on group. 2, 3, and 4, right? So, okay, what if I go this way though? 1, 2, 3, 4, 5, 6, right? So the first part actually didn't matter in this case, right? The hex 3-ene is I'm going to get either way. But now, you know, if possible, can I get lower numbers for the add-on groups? Sure. If I start with the green stuff here, look, my option is 1, 2 add-on, 3 add-on, 4 add-on, right? So the green ones here, 2, 3, 4. If I go from this side, it's going to be 3, 4, 5. What's better, 2, 3, 4 or 3, 4, 5, right? Well, 2, 3, 4 is lower numbers, so I probably want to start the left side here and use those, okay? So that doesn't, this is kind of a rare circumstance, I guess. This doesn't usually happen, but if it does, you still want to be thinking lowest numbers possible after you worry about the double bond, okay, kind of thing. So let's see here. What else do I need to do here? So on the 2 here, I said there's a methyl group. On the 3 here, there's a methyl group. And on the 4 is an ethyl. So I got 2 and 3 have methyls, right? So I would say 2, I'm not going to say 2 methyl, 3 methyl. I'm going to say 2, 3 dimethyl. 2 methyls, they're on 2 and 3. And the 4th one would have an ethyl. Okay? And the 4th one has an ethyl group, 2 carbons. Alphabetically, of course, now, right? So there is a lot of little things here, guys, that you need to worry about. 4 ethyl comes first, because ethyl comes before methyl. And 2, 3 dimethyl. Hex 3-ene. Okay? Is what you need to have for that one there. Yes? Questions, anyone? On that one. Okay. Good. Well, The good news is you're going to get a little more practice with this, because really, alkynes is exactly the same as alkenes, except for alkynes have a triple bond. Okay? Formula is a little bit different for that, but other than that, you're going to get the exact same practice. You do exactly the same stuff. So alkynes, of course, alkynes are unsaturated hydrocarbons again, of course, because they contain, they don't have single bonds, they have triple bonds. The formula for this one is H2N minus 2. We're going to take another 2 hydrogens off and put those 2 electrons together to form a triple bond. Okay? So let's take a look here. Same naming rules as alkenes. That's why we do them on the same day, but it just ends in Y and E instead. So, for example, if you're going to draw hex 2-ine, same, give you a little more practice here. Actually, why don't you guys go ahead and draw these 2 for me here. That'll give you a little bit of practice before you get your worksheet here. Hex 2-ine. So hex, once again, 6 carbons. 3, 4, 5, 6, 2 triple bond instead. So the YNE, of course, is the triple bond. Fill in the rest with H's. You'll need even less H's for this. There's 4 already there, guys. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. I need another 2. 1, 2. I need another 2. And 3 there. So hex 2-ine. Okay. 3-ethyl pent 1-ine. Pent is what? 1, 2, 3, 4, 5, 1-ine, okay, so put that in there, and then on the 3rd carbon I have an ethyl. Now remember, you got to get to this as quickly as possible when you name these. So 1, 2, this has to be carbon 1, of course, 2 and 3 ethyl, and that's an ethyl group there. Fill in the rest with H's, all good. 4, I need 1 there, I need 2 there, and I need 3 there. Okay? Good? That's not too bad, eh? A couple more on the next one here. Let's give you guys a chance to do those 2 drawings there, because that'll be fun. And that'll give you a little bit of a challenge, perhaps, on a few of them there as well. So you guys go ahead and think about those 2 there. So 3-ethyl, 6-methyl, oct 4-ine. Oct 4-ine, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. There we go. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, triple bond. Okay. For oct 4-ine. 3 has an ethyl. I started here to number those, so I probably should start here again. 1, 2, 3 has an ethyl. And 6 has a methyl, so that was 4, 5, 6 has a methyl, like so. Let's see. Yeah, and that should be good. Filling in the rest with H's, let's see. 3 there. I'll put 2 there. I got 1, 2, 3 bonds there. I'll put an H there. I got 4 there. I got 4 there. I need 1 H there, 2 there, and 3 there. Good? Yeah? Okay. The next one here is methyl bute 1-ine. Bute is 4. 1-ine means triple bond, or yeah, triple bond I should say. So there's the 1-ine, and now I need to put a methyl group on there. Well, notice that with this one they didn't put a number with this, so that just must mean a couple things, I guess. Must mean that I can only put this in one possible spot. Otherwise I'd have to have a number, or somebody didn't do this properly. I can't put the methyl group here, of course, right? Because then I change the length of the chain. I can't put it here at the end because I changed the length of the chain. Can I put it here? No, because this one's already got 4 bonds around it, so I can't put the methyl group here. I don't really have a choice. I have to put it there. So those are little things that you gotta kind of understand You know, four carbons can only form 4 bonds, of course, and in some cases you're not going to have a choice where to put that. I will put 1H here to make 4 bonds there. I have 4 there. We already talked about that. There's 1 there, and then of course another 3 there. All right. Good. Naming. All right. Naming is usually a little bit tougher, right? So let's do a little bit of practice with this. Do you guys want practice, or do you just want me to give her? It's up to you. You want to try? Yeah? Okay, you guys try. Look at the first one here. Remember, okay, you need the longest chain with obviously the triple bond, because that's the main feature in this one. So your options are 1, 2, 3, or 1, 2. You got to go with the lowest number. You have to start at that end. That's the main thing. The groups, if you can arrange them with the lowest numbers, fine. But that's secondary. You got to start with the lowest number. So I'm looking at this right here, and I'm thinking that this is carbon 1 and that's carbon 2. So this has to be called pent 2-ine to start with. So you got to start from the right in this case. All right. 1, 2, 3, 4 has, this is carbon 4, has a methyl on it, so I will call that 4-methyl pent 2-ine. The double or triple bond is more important than the add-on stuff, right? This one here is a big old mess. Is that good for everyone? Yes? Questions, anyone on that? We're good? This one here, let's see. We need the longest carbon chain with the triple bond, of course, or in some cases the double. 1, 2, 3, 4, 5, 6. That's pretty long. 1, 2, 3, 4, 5, 6, 7. Oh, there we go. That's the longest chain with the triple bond. Okay? You do have to be careful to make sure you find the longest one, because otherwise some of you guys are going to call that hex-ine, whatever the number is, but it's actually hept-ine, right, which is a big difference. So let's see here. Obviously this is going to be, like I said, hept something ine. Let's decide here. If I start at this one, 1, 2, 3, or 1, 2, 3, 4. I got to start from here. That's going to be 1 right there, 2, 3, because I'm going to get to the triple bond quicker that way. So that's hept 3-ine. Triple bond's the main feature, right? Everybody wants to see the triple bond. It's like the triple axle. Something like that, I don't know. Right? Triple flip. 1, 2 methyls. So I got 2 methyls on 2 and 2. And it looks like to me I got a methyl on here and a methyl on there. So that's 4 methyls that I can basically summarize with a tetramethyl here. Tetramethyl. And it looks like to me I got a 2 and a 2, 3, 4, and a 5 and a 5. Okay, because this is carbon number 5. And I have to start at the same end, of course, as my triple bond was. So I got to start on that end. If that's the end I decide how I'm going to get to the triple bond quickest, I need to start at that end to name the branches. Okay, you can't reverse it now and decide that this is going to be carbon 1 here. So if this is carbon 1, that's 2 and 2 and 5 and 5. So I'm going to put here 2, 2, 5, 5, tetramethyl hept 3-ine. Yep. Because there's basically what you're saying is there's four methyl groups. And even though they happen to be on the same carbon, you need to have 4 numbers to describe their location all the time. There's no exception for the rule. Because they could have been 2, 3, 4, 5, for example. Well, those are all different. You need to have the 4 numbers. I realize that. Even if they're the same number, you got to have, if you're saying it's tetramethyl, you got to tell me that there is exactly where those are located. There's 4 methyls. Where exactly are they? Okay? There's no exceptions. And if it was trimethyl, you need to have 3 numbers, and 2 of those might be the same. It doesn't matter. You got to have 3 numbers. Okay? Yeah, you can't get away without that. All right? So, good? Questions, anyone? Yes, no? Okay. Physical properties of alkenes and alkynes. Alkenes and alkynes are nonpolar, again, molecules which do not dissolve into water. So once again, you know, when you're making your little cheat sheets here, your little notes, This is things I would be putting down here, right? They will dissolve in nonpolar solvents. They don't dissolve in water, okay? But they will dissolve in nonpolar solvents. Alkenes have 2 fewer H atoms than alkanes. Alkynes have 4 fewer H atoms than alkanes. Of course, that comes from the formula, right? We said alkanes are all single bonds. It's 2n plus 2. If we take those 2 off, we're going to have 2 less hydrogens. If we take another 2 off to make an alkyne, of course, well, technically there's 4 less hydrogens than alkanes. All right. As the molecule's electron cloud becomes slightly smaller, basically what happens is when you are making these double bonds here and things like that, okay, the electron cloud, basically the electrons around this molecule, becomes smaller. A slightly weaker London force exists and results in slightly lower melting boiling points than similar sized alkanes. Okay, so what they're basically saying here is, for example, if you had pentane and let's say 1-ene, okay, out of the 2 of these, I would expect the pentane to have a higher melting boiling point. Okay, so out of the 2 of these, this one would be stronger. And let's say I'll do another one here, pent-1-ine. This would be the weakest one here. All right. So similarly sized alkanes versus alkenes, that tends to be the pattern that you see. Okay. Now that might not be, you know, once again, you'd have to, I'm sure there's probably some exceptions and things like that, but that's generally the pattern that you would see. The highest melting boiling points, the strongest ones would be the single bond saturated hydrocarbons, pentane. And if you had a similarly sized, in other words, if you have another 5-carbon chain, but with a double bond, it would be a little bit less melting boiling point, probably a little bit lower, and pent-1-ine would be even a little bit less than that. Okay? That's generally the trend that you would see. That's also good to know. Okay? Important to know. All right? Questions, anyone? Alkenes, alkynes? Okay. You need to have, the biggest thing with this unit here, I think, honestly, this is, like I've told you before, this is, oh, I got one more thing to show you here real quick. I just want to bring that up from actually yesterday. But the biggest thing here in this unit, I'm going to tell you straight up, is this. And you're probably not going to want to hear this for some of you that don't like to do this, but it's just practice. You need lots and lots of practice to see all the different types of shapes and all the, get practice naming them, get practice drawing them. You just need practice. Practice? We're talking about practice? Oh, here we go again, right? No, because we're playoffs now, right? So now no. Anyway, but you need practice, okay? And where are you going to get practice from? You got to do the homework. You got to do the questions, okay? I mean, it was the same last unit, but then you probably had to do, you know, there was extra stuff on top of that. This is practice, practice, practice. You need lots of practice drawing these, naming these. Because, I mean, the slightest little mistake here or there is going to be the difference between right and wrong on these ones, okay? So you really need to have, like I said, do all your homework, practice. I just want to show you this one here because I did this with my other class here. How many do I got here? 1, 2, 3, 4, 8. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. And then off this one here, I got 2 of those. And I have 1 off of here. Okay. Now, this one here is all single bonds, so this goes back to yesterday. This is an alkane, of course. I will fill in the rest here. But I just want to mention something about naming this one here. And you guys can copy this one down somewhere too. You might even have a space on the back somewhere. Now, this one here, first of all, when I look at this, I say, hey, this is all single bonds. I know that this is an alkane. It's a saturated hydrocarbon, we call this, right? Single bonds. And I would find the longest chain possible, of course. I don't have to worry about double or triple stuff. Just find the longest chain possible. So I would do that. So I would say, okay, longest chain possible. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Well, I'll go with this one here. Now, this one here, sometimes this can happen. And once again, this is one of those little things that you have to be aware of. Okay, so how am I going to name this? Well, hopefully, most of you guys would start here. That's 8 in a row. That's oct, all single bonds, so that's octane from yesterday, right? So I'd start with say that's octane. Now I'm going to start at the end. How do I name anes or single bonds? I got to get to the groups as fast as possible. So my option is 1, 2, 3, and this is what? What group's that again? Ethyl. I got 1, 2, 3, and this is a methyl, right? So it looks like if I start from the left side, I get a 3, and if I start from the right side, I get a 3, right? So is there a right way to name this, or does it really matter? Because from that side I get 3, and from this side I get 3 to the first one. And by the way, if I keep going here, this is a 4, 5, 6, and this is a 4, 5, 6. So I'm either going to have 3. I'm going to have 3 and 6 either way, correct? And I'm either going to have ethyl or methyl, whichever one. What do? Do I start from the left, right, or I don't care? Does it matter? You probably should start from the left, right? So why? Well, because when it comes down to it, okay, 3, 4, 5, and I'm going to put this as a 6 here. So look, 3 is going to have an ethyl on it. So I'm going to start this way and go that way, okay? And I'll show you the reason why. 3 is a ethyl, 6 turns out to be a methyl. Remember, and you might say, well, if I went the other way, it's 3 methyl, 6 ethyl, right? It's just the opposite. But you have to put these alphabetically, right? So you say, well, hey, look, I could get the same numbers either way, but which one's a little bit better? Well, the one that goes lowest number, alphabetical in this case, would probably be a little bit better, because 3 ethyl kind of go together, lowest number, alphabetical. 6 methyl, right, is a little bit higher alphabetically and higher number. So that's what you probably should do in this case here. 3 ethyl, 6 methyl. Now, like I said, ultimately that's one very rare example, right? But that's little things that you need to think about as well, right? Will you get a question like that? Honestly, probably not on the diploma, okay? Will we give you that on a quiz? Possibly, because we like to challenge you. But those are the little things that you kind of got to pay attention to, right? Like I said, normally, are you going to have that issue? No, normally you're going to name them lowest numbers first, and then alphabetical, of course, whatever that happens to be. But this case just happens that the numbers are the same, so I can match up the lower number with alphabetical, and that's a good thing, okay? So that's the only other one I want to show you there. All right, I got some questions for you.